Alrighty, race fans, welcome to another edition of the Workbench. Well, today we're going to take a look at maybe doing some fine-tuning and hop-ups or whatever to Super 7. So let's just jump right in. Alright, for purposes of this discussion, we're going to kind of concentrate on the Super 7 GTS version. Mainly because it's intended for more serious club racing on routed tracks. The SC with the fat tire, there's no point in trying to talk about hop-ups, because if you do, you end up with GTS. But here we're going to take a look at some fine-tuning tips that, if you're in a very competitive environment, might actually get you some extra speed, better handling, and those sorts of things. So a couple of things. We've got an infrared heat gun here, and that will help us check some things here. That we'll actually do some track testing. We've got a VRP dyno. This particular unit's been customized by VRP. I won't get into all of that, but the way I use a dyno, what he did out of the box didn't really suit me, so I sent it back and had him make some modifications to it. We'll talk about chassis setup before you start building one. We'll talk about different gear ratios, and we're going to talk about how to fine-tune these can motors just a touch. Okay, alright, so we'll reset here and start into it. Okay, to start off with, before you get into building the chassis, there's a couple things that you need to be aware of. One of the issues with any injection molding process is you have to account for the shrinkage of the plastic. So in this particular drawing right here of the chassis, they can't make the mold to these neat little dimensions here, because then if you did that and shot the mold, because plastic shrinks when it cools, you would end up with something that's too small. Alright, and that would definitely not be a good situation. Other things can happen in the mold making process, and with the Super 7, I had the axle holes called out, the rear axle hole at 063 and the front axle holes at 050. As the chassis comes out of the mold, all of these other dimensions are right on it, but for whatever reason, the way the side slides work with things that create these hole features or whatever, there's just a touch of flash in these holes here, and it's netted a rear axle hole effective dimension as the part sets at like 060 and the front at about 048. Well, the front axles are about 047, so that works out pretty good. The issue I have is the rear axle hole, because there's some minor amount of flash in there. The standard axles are 059, so when you put it in, it is, in my opinion, a little bit tight. So what I do before I assemble these chassis, I've got this little tool right here. I'll show you what to do with this axle here in a minute. But I just kind of wiggle it around a little bit, and then go in the other side, in and out a couple times, and wiggle it around a little bit, and that kind of clears the flashing out of the hole. You can use something like this and then do the wallow like that, and that'll clear the flashing. Okay, so when you're building these cars, if you do that, when you then pop the axle in, this is what you want. This is how you test it. Okay, just that thing needs to flop back and forth freely. It depends on you know, at what point in the production run a chassis is, you know, is the guy watching the machine close enough? There's just all kinds of things within a particular run of material that can affect flashing, you know, heat, pressure, all of that. And it's really, quite honestly, difficult to control. Flashing out here in these areas, I think probably is a little easier to control because the features in the mold are, you can probably machine these and get, you know, the tolerance is a lot closer. But what they're having to do here is basically use pins to go through and create these features, and I think it's just about a near impossibility to get that pin to go through and lock up on the backside and not create some little minor amount of flashing. So the cheap workaround is to make the hole like really big, okay, say 64, 65, and then if there's flashing, you don't worry about it. Well, then what happens when you know, wear the flashing down, then you've got this, you know, really bad hole that is way too large, and you would have a lot of flex in the chassis going this way as the axle would wallow around. And when all that happens, if that's too big, in my opinion, then it may be more subject to popping out in a crash. Okay, so just before you put your cars together, just check those back axle holes, clear the flashing, and you'll have a far better build. And because a lot of times when this axle is just a touch tight, you go to run the car and the car won't have any run down. It sounds a little bound up, and over time, the plastic actually has natural lubricity, so the axle won't wear the flashing away much. Popping the axle in and out might, but it's not something to be taken lightly. So do that and you'll have a better build right out of the box. Excuse me. Alright, in this next little segment, what we're going to do is pop a brand new motor into a chassis, put the axle in and get it to run, and just basically a green motor that's not broken in, and run a dyno number on it and see where we're at. So first of all, I take the little contacts and bend them over so you've got little arches there. Okay, and I'll pop that thing in there. I want to get my little tool that helps me get these in without bending them. You just don't want to cram this thing down in the chassis, because what will happen is it'll break those things off or bend them up and it'll look stupid. So I generally kind of get one side started, down in there. Okay, so it looks pretty good. Let me check it on my 9-volt, make sure we got continuity. Yep. Okay. And check to make sure we got a little in play in the motor. Yep, got a little in play. Alright, we get our magnets in. We'll put it in high downforce. Get our clip on. Okay. Okay, get a little oil on that bushing. Yep. Alright. So the back axle that comes in the car is a 23 tooth, 7/23 gear ratio. Okay, now I'm going to adjust the pinion out just a touch. Okay. Alright. So this is basically a green motor that is not broken in. Alright, so now let's set up our dyno and see what happens. Alright, got the car on the dyno. Okay, so that is about 10 volts. And this number here, it's really arbitrary, okay? It's not, I'm not sure you can correlate it to anything. It's basically representing an RPM number because the drum is passing essentially a Hall sensor, okay, that's measuring RPM, and then that creates a voltage number, and that reads out. So as the brushes are breaking in, you can hear it kind of pick up speed a little bit. And this will be the case, this is the case with any DC brushed motor. I mean, things just have to seat in a little bit. Now when I'm building these cars, as I go through the process of getting things together, it's on and off a 9-volt battery, so there's some breaking in there. The cars are track tested. I break them in there. During assembly, I use this little block where I put the leads on, and I'll put the car on this test block, and this allows the back end to freewheel. I'll put this up there and then put voltage to it, and while I'm working on another car, I'll let the car run, and that breaks the car in as well, freewheeling like that. I don't get out the dyno and wear it out like that. But and then basically at that point, then track test the car once all that. So they're relatively broken in when you get them. So. Alright, so we're about 14.5 volts. Alright, that's 18 volts. It's getting a little bit better. Alright, so 3.7's probably a fair number for this motor. You know, every motor will be slightly different, but they'll be within a range. So, you know, let's mark that down somewhere on a piece of paper. Let me get my marker, and I'm going to write over here off to the side, 3.7 and that. So let's then get into trying to tweak this motor a little bit and see if we get any better results. Alright, so we're going to tweak the motor. Specifically, we're going to look at doing the end bell, because your speed with these cars, any of these cars, comes with your entire electrical path for the most part. Yeah, gear mesh has something to do with it and all of that, but if you don't have a good electrical path, you just got some problems. So this is what, you know, tweaking this motor is going to do for us. All right, so these can motor straps are aluminum. All right, and take note of this, they're slightly bent in here, so you get yourself some little bitty screwdriver like this. All right, and then I get something hard, and I go in and I straighten out those tabs. It's hard for you to see, I know, but I gotta keep this thing down on a hard surface and then wedge my screwdriver in there and get those tabs straight. So now if you look at them now, you can see that the tabs are straight. And now this should easily just pop out of the motor, and we get our little M-bell spreader tool, spread the brushes, and pull the armature out. Okay, now we'll talk about putting that back together here in a minute and how to keep you from getting things out of whack. Alright, couple little tune-up tools. I have a standard old battery-powered Dremel with an adjustable chuck, and I'm going to chuck this armature up in this Dremel, and you get one of these Euro tools. Okay, it's called a scratch brush, but it's about the size of a ballpoint pen. Other ones are as big as a Sharpie, and you don't want those. You want this thing here, or some type of scratch brush that is about the size of a ballpoint pen. Euro tool, Germany, it's the best. Okay, just cry once. Right, turn this on low speed, and if you look at the commutator, you see the brush marks from the brushes. We want to polish this up a little bit. See, so now our commutator's polished. Right, that's an important step. I do that. Then the next thing is to add some brush tension. If you spread the brushes, okay, take pressure off, right, you'll see that the opposite brush arm comes down a little bit. All right, that's good on that one. All right, we'll do this one here. Same there, but we can add a little bit more tension. What I do is I'll take my tool and get up in here and kind of press down a little bit on this bend of the brush back up in here. Okay, pushing down here is not going to do much. So now I think we've got a touch more. You can add some more tension by using, you know, a tool like this to actually bend this arm a little bit more. So I'm going to go in here, and I know you're not going to be able to see this very well. Give a little bit more tension there. Bend it just a touch more there. So now when you look at it, you see the brushes are slightly offset. Okay, that's kind of good. And then if you look now, we got a lot more tension. Okay, see that? Alright, and then the final thing is pre-arcing the brushes. We'll talk about this tool here in just a second. But what this thing is designed to do is, well, I need to get another one here. Hang on one second. Alright, back at you. Alright, these two tools, the actual little pilots, two different sizes, so it's kind of important to get the right size pilot for the bushing. So pop that in there, let the pressure off, and then I just kind of zuba back and forth. Okay, and this is a diamond tool, so what this is doing is pre-arcing the brushes, which in the factory they don't do it. There's a technical reason why. It doesn't make any difference here, but this is just the way the parts are made. Don't do it a whole lot. I would not necessarily do it under power because you could ruin stuff real quick. So now if you look, you'll see a slight arc in there. So let's go ahead and cut it some more. Yeah, I kind of like that. Okay, so we've added tension and we've pre-arced the brushes. So let's get our motor put back together. Now, one thing to note, guys, if you want to try to change armatures, pay attention. The spacing between the front of this and the back of this little collar here, okay, when they put these can motors together, they calculate what this space needs to be, and it is a touch tighter than a similar space if you were to, say, measure a Viper car. Okay, so the actual motor, this motor here is the same basic 6 ohm armature that we use in a 6 ohm Viper. It's the same motor, okay, not any different. It's the same exact specification. There is a slight difference in the specification of the spacing of this washer on the back. So if you were to take, say, a low ohm Viper motor to put in here for maybe a drag race car, this space is going to be increased, okay? And when you put these motors together, you need a little bit of fore-aft play. You got to feel it. You got to be able to see a little bit of it, and you got to feel it, because if you put this thing together and it is even in a slight bind, you'll increase your amp draw, lose speed, possibly burn up the motor. So what I do is get it in our handy little press, and just ever so slightly, just give it a little, just a slight push, okay? And that'll push that ring in. It doesn't have to be much. All right, so on these can motors, what I like to do is go on ahead and load the armature into the end bell assembly, and I generally leave all this together. You want, in these particular can motors, the Super 7 motors, you want this red mark up, okay, white magnet up, and I grasp it like this, because if you don't, the magnets tend to want to suck it out of your hand. Okay, pop that thing in there like that, okay, check my fore and aft play, okay, and then I get my screwdriver and just kind of push back down on those aluminum tabs, and that'll lock it back in. Okay. Give it maybe a little test. Alright, so we know we got continuity, we're doing good. So get our okay, got that. We've got to put our pinion back on. Put our clip back on. It looks good there. Get our axle in. Give it just a touch of lubrication again, because we took everything apart. I don't know if you can hear it, they're rumbling around upstairs. Alright, double check it on a 9 volt. Alright, so let's see if we made any improvement. Alright, I'm going to be really mad at myself, because I'm not fudging nothing. This is all done in real time, so we're going to see firsthand if this really makes a difference. I know on the track it does with other cars, okay? Actually, not quite as fast. There we go. I tend to keep my finger on the pickup shoes to kind of help the contact That, with this dyno, you get a little bit of, you see how it drops down, and I just take and put a little bit more contact pressure. So we've gone up a little bit on the dyno number, just a touch, half a point. All right, so the next thing we're going to try to help break this thing in is comm drops. Now, there's probably plenty of information on YouTube about comm drops. This is just what I have here. This is Voodoo. The best I can tell, this is like a fancied up mineral spirits is really what it is. You know, with colorant, maybe a few of the little things added. But mineral spirits is kind of a cleaning as well as a lubricating agent. It's really kind of an interesting fluid. And, you know, guys in the 1/24th world, they've used stuff like this on their braids, brushes, whatever else. So I'm not going to flood it, but what I'm going to do is just put a little drop maybe there and try to get it up on the commutator there, just a little bit, not a whole lot. Okay, and let's see what this does to our RPMs. So it gets it up a little bit, another half a point or so. And then as it kind of burns out, you watch the RPMs come back down a little bit. But I think it kind of helps seat the brushes better, is my point. Right, so we've done a lot of work to the car and we've gotten a little bit more out of it, okay? And that's kind of the point. You know, racing is a game at the margin, so every little thing that we can do helps build margin in the car. Okay, we're going to now take a look at a temperature gun and how that can maybe help you tune a car. It may or may not help you make the car go faster, but it may help the car last in a race, and we'll talk about how that works. So I have one of these, you know, cheap Chinese things, and you can sit there and it's got a laser and it'll tell you what, you know, that wooden block is basically room temperature right there, okay? But you've got to hold this sensor pretty much right over the car. You know, don't get out here and try to do it. Get this sensor right down pretty close. So I get it right on top of the car, and I'm looking at, you know, kind of go up and down a little bit. So, you know, right around 90 degrees. Right, and I use some canned air to kind of cool it down. So let's run it. And let it run for 30 seconds. Okay, so 100, 102, that's really good. That's really, really good. Now, on track, that's probably going to be much higher, probably in the 130s, because you're actually on and off the throttle, more of a magnetic load. So what I want to do now is change axle sets and see if we can demonstrate how a gear ratio may affect or may not affect heat. Alright, so we went from a 23 to a 25 tooth. And get my canned air, kind of Cool the thing down a little bit. Double check my temperature, so we're back down in the 70s. Alright, so we had a 23 tooth in, which is the standard gear ratio that the SC and the GTS is shipped with. We've gone to a 25 tooth. This is one's actually from RPMs. So let's crank it up. Now the interesting thing is we have an RPM number that really isn't much lower than the taller gear. At least the wheel RPM. I think the motor in and of itself may be at a higher RPM slightly. I don't have a way to exactly measure the RPM of the motor, but with simple math, you could measure all of this and determine what the effective RPMs of the motor are doing. We're not going to get into that. Okay. And let's see what the temperature is on this now. Let it run a little bit longer. So we are a couple of degrees higher. That may be, well, about the same. No real effect, within a degree or two. Right, so what I want to try to demonstrate then, and this is going to be subjective, is what a taller gear ratio or a lower gear ratio does for driving and handling characteristics of these cars, okay, especially when you're in a competitive environment. Generally, the taller gear, which would be the 723, you're going to give up a little bit of torque. So when you are accelerating down the straightaway, it's going to take a little bit longer, slightly longer, to get to speed, but you will have more speed at the end of the straightaway. All right, so that's one thing. Now, when you go with a 25, in particular, something like this, where you're running a 4x16, a 3x5, a 3x14, something in that area, the car with the lower gear ratio, it will get up to speed quicker, and you tend to keep the RPMs up in the motor, even in the infield. Okay, and a number of years ago when we were racing SRTs in our club, a lot of guys thought they wanted to go with 23s. I always stuck with a 25, and I won a lot of races with a 725 ratio in the SRT world. And I felt that the car just, the RPMs just stayed up, and for whatever reason, I think that helped the car in handling and not making trigger inputs. So, all right, we'll break and we'll set up pointing at the track here. Well, I lied. We're back. Had another thought. One thing that I have done in this test versus the standard GTS as you get it, I've gone to a firm tire. This is a 438 firm, and the car has plenty of downforce, and what happens here is the tire doesn't squish as much, and I think it helps the car turn some in that, and I think you just get a lot better acceleration with the firm tire over the medium tire. And I'm going to show you one other little trick here. You get pretty coarse piece of sandpaper, and this only works, by the way, on these firm tires. This trick does not work on the medium tires. The material flows too much, and what we're trying to do is round off this inside edge, because that does affect handling. Over time, if you didn't do this, you would end up wearing it in. This just kind of accelerates that process. Sometimes I'll just kind of even out the, not very hard, just scuff it up a little bit. Get some of that shine off. So you're pre-scuffing your tires. You don't have to worry about the outside edge because it's already rounded. So, you know, dressing the tires does help a little bit. All right, so I want to get a little bit of alcohol on a rag. And clean that back up. All right, now we're ready to go over the track. Okay, so we don't have a lap timer on this track. I don't know, this thing's been set up for like, I don't know, a dozen years, and I've never actually put a permanent lap counter on it. I think mainly because I just don't have the space and whatever to do this with. But we'll start off with the 7:23 ratio. Pretty good. Let's check our temperature. Alright, so on track right now we are probably 118-ish, 120. That's good. We really don't want to get up like 160 in that area. That's you'll get too much heat running down the armature shaft, and over time, if you've got some mechanical problem where things are bound up and you run it up to 180, then the pinion gear will start to kind of loosen up and let go. Cool that down a little bit. Alright, we're in our 80s, and this is now a 725. Alright, so my ear tells me I'm making more RPMs down the straightaway. And the car feels better, drives better, and our temperature like 110-ish. So on the track, we gave the car more torqueability, and it takes heat out of the car. So my recommendation, if you're in a really tough environment, I would do a couple of these little things. Tweak your car up, go to a harder tire, firm tire, drop the gear ratio to a 725, you know, do your in-belt tweaking tricks or whatever. These cars come with, you know, the heat-treated hangers, the low-profile shoes, and I think this particular example, I dropped the front tire size. I didn't talk about this earlier. The size that comes on the car is, I think, 340. I dropped this to a 325. So one of the things that I've found with a Super 7 versus, say, a Viper, a Super 7 doesn't like to be drug around, and by that I mean slam down to where, you know, your magnets are touching the rail. And we'll have an example here in a minute of what that actually is like. The car seems to handle better when it's got clearance and is reasonably quiet. So on a tech block, I don't know if you can see this or not, but when you look at this light space here, you'll basically see that the car has a slight rake to it. I'm just going to exaggerate it, okay? It's there, as opposed to using a really smaller, let's just say a 328, or excuse me, a 428 rear tire. This is now 434 or 436 firm rear tire. So, but if you drop it down to like a 28 or something, then the back end is going to be down. You'll be, dragging your magnets or whatever. The car just seems to handle better with the clearance. So you've got to make sure, especially like if you're running on a plastic track, okay, you may have to raise the front of it up a little bit so the car has more clearance over the rails, because once you hit high rails or whatever, that causes odd handling. So there's that. Now I got an example here of a Viper. It's a V-spec setup for spec racer, and it is a 7:23 gear ratio. It's running the albino firm tires. We've got our maxi wing magnets in it, the new end bell. We're running a helper spring in that. And when you listen to this car is hitting, and with the Viper, that's okay, but you can see we've got wear on the motor magnets and we've got rail marks on the traction magnets, so we're really maximizing all of our contact. And with a Viper, it just runs good handles good, in my opinion, when you're skimming the rails all the time. Super 7, it likes to have some clearance. So let's check the temperature on this one real quick and see what we're running at. It's actually about the same, so that's really good. Even with the car dragging around a little bit, we're still in the hundreds. A lot of times these cars in a race or whatever, you'll get these things running up into the 150, 160 range. It's just a lot different racing environment with these than, say, the Super 7. I wouldn't recommend running a Super 7 that high in terms of temperature. These compression molded magnets in the motor, they'll take a little bit more heat before they start to lose gauss, because any magnet loses strength when it gets hot. These are ceramic, and my thinking is probably when you get that much heat, you're going to start losing speed. And when the car does get hot, you'll kind of see it slow down a little bit. The speed will go away. That is a red flag that you need to pull off before you throw a rod, essentially. Throw a wire or do something's burning up. But once the car is going around a track and it's got this predictable sound and predictable feel or whatever, if it starts to kind of slow up a little bit, it's telling you something. Pull off, figure out what's going on, why the car is generating heat, and save parts. All right, little recap. So we've talked about how to get a little bit more out of a essentially box stock Super 7 GTS car. It's impossible at the price point these are being sold at for me to do all these little tweaks to have this happen. And now in the future, could I offer a flavor of this where I've gone through on one and done all this? Yeah, but it could be, a $75, $80, $90 car by the time, account for all your time and tweaking and whatever. So I'm trying to give you guys an idea of what you can do to affect your own tweaks and get, extra margin in the car, because racing is a game at the margin. If you can build margin in the car and your competitors haven't, you can kind of lay back a little bit, and when you need the speed, you got it. Okay, so you need to work with tire height, tire compound. Generally, as a rule, if if you are running a specific size, let's just for discussion purposes say 440 in a medium tire. If you run a firm tire, you can generally drop the size down at least 1 because the tire is not compressing as much, okay, and it's because it's harder. It's like running higher air pressure, and you get really snappy acceleration with these firmer tires. With the standard issue car with the medium tire, the cars are set up to kind of work good in a variety of applications. You know, what we're talking about today is stuff that you have to do to tune your car to your conditions, okay? And what we've done here reflects better performance on that track over there. And that's a Brad Bowman track, when, you know, plus or minus 14 thousandths rails. You know, if it's a Viper track, if it's could be made out of PVC, this is a Cincher track, okay? All of that goes into how the car handles or whatever, and you've got to be able to figure this out. And if you're in a club environment and you're running different tracks, obviously layouts are different, but you know, the surface texture from Jimmy's track to Larry's track might be different because it could be made by 2 different people, okay? You've got to think about that and be able to account for it. So you may have a number of different axle sets set up, different gear for different tracks or whatever. So you've got to be able to keep track of all that. I'm just trying to show you the steps that I go through to get a car optimized for my conditions over there, okay? But the same basic thought process works across the board. All right, so you got any questions or comments or whatever, you can certainly leave them in the comments below. I don't, as I remind people, I don't hang out on YouTube a lot to sit there and read all these comments. I mean, I'm too busy doing other stuff. So it's better if you have a really important question to send me an email. Do not text me, please. That just is an aggravation. However, a phone call is, you know, actually easier for me to you know, have a discussion with you on what you're trying to do. But email and phone calls generally is better if you want a timely response. Like I say, I just don't hang out there on YouTube every day and with, you know, nothing to do and all day to do it in. You know, we stay busy. So, all right, guys, thanks for your help, and we will see you in the next one.